So this is a divergent improper integral example. Okay, and this is with an infinite bound again. Okay, so here's the function, the graph we're going to look at. So now we're looking at a graph that looks like this and like this. Okay, and this is y equals 1 over x. And so what we're going to look at is going to be this area where we're going to start with x equals 1. And again, we want for our t to go to infinity. So you can imagine a t here that I'm going to have go out to infinity. Okay, so the area that I want to look at here is the area like this. Okay, so let's go ahead and do this. So what I'm taking here, so I'm going to take the integral. I am actually going to switch to yellow. My green is kind of running out. And so I'm going to take the integral, and I'm going to go from 1 to infinity. So this is going to go from 1 up to infinity. And then I'm going to get 1 over x dx. Okay, and so again, I'm going to do something very similar to whatever I did over there. So I'm going to replace this bound with a t. I'm going to keep the bottom bound as 1. I'm going to keep this as 1 over x dx. But then I want to replace that infinity with a t so that I'm only looking at this finite area from t to the left there. And then when I take the limit, I'll get the entire area. Okay, so this is going to equal for me. Oops, I forgot to put t goes to infinity. That's important. So I'm going to get the limit as t goes to infinity of, and then I'm going to get, so I need to integrate this inside some parentheses. Always good to use our parentheses. So this is going to be the natural log of the absolute value of x from 1 to t. From, and then we go t's on top, 1's on bottom. Okay, and we notice that these absolute value here is not actually important because we're dealing with values here that are positive. Okay, so what we're going to actually get here, so this is going to equal the limit as t goes to infinity of, and so we want to sub in each of those and subtract. So we want ln of, and as I said before, because this is because these values are positive, we can just kind of drop the absolute value there and just write this. Again, replacing our x with parentheses. So our top one is going to be a t. Our bottom one is going to be a 1. And then we think for a moment and we remember that the natural log of 1 is going to be 0. Okay? So we know that this one here is 0, always. Okay? But now we have to think about what this is. And let's do this in a box over here. So if we say that ln of t equals y, this is the same thing as saying that e to the y equals t. Okay? But we want for t to get infinitely big, right? So we have to figure out what needs to happen with y okay? And y is going to get infinitely big, okay? So this is going to give me, so this is going to approach infinity. So let's just write this first that we have. So the limit as t approaches infinity of, and then we have the natural log of t. And looking at this up here, this tells me, right? So this gets very big when y gets very big. Right, that's the thing to keep in mind. So I need y to be getting really big, which means that this limit is actually going to output for me infinity. Okay, but what does that actually mean? So this tells me that it diverges. Okay, this tells me the integral diverges because the output is infinity. Okay, so I want to make a similar remark, which is that similarly, oops. Okay, we have that, so similar to this one over here, we have that the integral from minus infinity to minus 1 of 1 over x squared dx equals 1, okay? So is convergent. Okay, and for this one over here, what we want to look at is if I have the integral from minus infinity to 1, oops, minus 1. We can't do it to 1 because then we're dealing also with what's going on in there. That's a whole nother ball game. Okay, so this of 1 over x dx is going to equal, okay, if you look at this, this is actually going to equal minus infinity, right, because it's like minus infinite area. If this is positive infinite area, this one's minus infinite area because there's kind of symmetry, except that this one's on the bottom. Okay, so also diverges. Okay, so these are kind of the examples or pictures to have in mind for convergent and divergent integrals, or one of your bounds is infinite. And then we can kind of go into the more general setting in the next lecture. So I will see you in the next lecture.